Alright, 4.4 optimization. We're using modeling to create an equation and ultimately calculus to find the min and max of things. A lot of times we're trying to maximize the volume of something or maximize profit. You might be asked to find the minimum time of something or minimum cost. So you're finding either a maximum or minimum of something. I'll do an example. Let's say I want to find the maximum area of a rectangle with perimeter of 20, we'll say. Alright, so maximum area. First thing you want to do is make a sketch. So we have a rectangle. We're going to label our variables. That is not how you spell label. A label. And we'll say X is one side. And then if it's a rectangle, then the opposite side would be the same. And then this side, well, we have 20 to work with. Called 20 centimeters. So this is 20 minus what we've used. But then we have two sides remaining, so we have to divide that by 2. So 10 minus x is what these two sides are going to be. Alright, so we have it labeled. Next thing we want to do is find an equation to relate the variables. We're looking for the maximum area, so we're going to have an area equation. Area of a rectangle is base times height, so x times 10 minus x. So once we have our equation, that's a big part of it. Now we just want to find the derivative, because that will be where we have a horizontal tangent, either a max or a min. So finding the derivative, so a prime, well, maybe I'll distribute, so 10x minus x squared, so a prime is 10 minus 2x. Set derivative equal to 0 and solve. So pretty easy problem. So x equals 5. Okay, and then we're not done until we answer the question. So make sure whatever question is given, we answer it. So we're trying to find the maximum area. Well, the maximum occurs at 5, and we feel good that it's a maximum because if we're trying to find the minimum, if that were a minimum, it wouldn't make sense that we'd have a 5 by 5 rectangle. It would be, imagine a really skinny, flat rectangle to produce the minimum area. Here, 5 is going to be a maximum. Also, if you look at the type of a function we have here, it's a parabola. It opens down, so if we have a horizontal tangent, that is going to be the maximum. Okay, so at 5, we can plug it in. 5 times 10 minus 5 times 5, so our answer is 25 centimeters squared. Maximum area. Alright, so that's about as basic of a problem as you can do, but the process is the same. I made it in 5 steps. So let's do another one. One thing about this section, every problem is different than the last one, which is fun and exciting, but it also doesn't make it all that easy. Alright, so let's say we've got a cylinder and we want to find the minimum weight of the cylinder, and when the volume is, we'll say it's 100 pi inches cubed. Okay, so if we're trying to find the minimum weight, and this is like a sheet metal container. So imagine if we're trying to find the minimum weight, we're actually finding the minimum surface area, because anywhere we have a surface area, that's where the sheet metal exists, and we'll say that it's open top. Okay, so if we minimize the surface area, then we'll minimize the weight, but the constraint is you have to have 100 pi inches cubed for its volume. Alright, so if we're minimizing surface area, I'll do capital S for surface area. That's the area of the bottom plus the lateral area, which is just, you can imagine unwinding this, and it's 2 pi r all the way around times the height. So it's 2 pi r times the height is the lateral area. So there's our equation. Problem is we have more than one variable over here, and we haven't used the fact that the volume is 100 pi. So if the volume is 100 pi, and we know that the volume of a cylinder is the area of the base times the height, so the volume equals pi r squared h. So 100 pi equals pi r squared h. I think I'll solve for h, so I get 100 pi over pi r squared. So h is 100 over r squared. So now we can rewrite this by putting 100 over r squared in for h. So our new updated surface area equation is this, which is pi r squared plus 200 pi over r. Alright, so that's a lot of the work. The rest is just finding the derivative, set equal to 0, and answering the question. Okay, so S prime equals 2 pi r plus, I'll think of this as 200 pi r to the negative 1. 200 pi r to the negative 1, so I can avoid the quotient rule. So the derivative of that would be negative 200 pi r to the negative 2. Set equal to 0. Move that guy over. See if I can do this in the amount of paper I have here. Multiply by r squared. So I have 200 pi equals 2 pi r cubed. Solving for r, I'm going to divide by 2 pi. So I get 100 equals r cubed. So r equals the cube root of 100. Alright, so there's our r. What is the minimum weight? So the minimum surface area, here's our surface area equation right here. So I can plug the cube root of 100 in for r here and r here, and we get our answer. And surface area would be in inches squared, whatever you get when you plug that in. Alright, so lots of different types of questions in 4.4. There's a couple different examples.